My tools are a part of me. The more powerful the tool, the greater that piece of me it makes up. Without them, I look like this. Today, we'll use those tools to try and make cornhole boards 80% more portable while maintaining 100% of the playing experience. We'll show you how to incorporate 2 unique hinges into any CNC project. You'll get a comparison of 1/2 inch and 1/4 inch tooling, and you know you're going to get more information, ideas, and inspiration throughout. So, let's get started. The boards have 3 basic requirements: 4 feet long, 2 feet wide, and 12 inches tall at the tail. They are a classic constrained design project. Something where you must honor a list of basic parameters, but the rest is a blank canvas. This has made cornhole boards a woodworking rite of passage. So of course, 15 plus years ago, I made a set of boards for myself, with the help of my boys. This quickly led to making sets of boards for friends. Years on, with more skills and more tools, I wanted to see if I could make cornhole boards easier to transport to all the places they should go. Constraints in place, it's off to the computer. Particularly when creating 2D parts, Carbide Create can be super powerful while not adding a ton of complexity. For many creative projects, complex CAD programs are overkill. Remember, CAD programs are just tools. I own a variety of wrenches, screwdrivers, hammers, and more. When I have a project, one of the first tasks is choosing the right type, size, and shape of tool for the job. Starting a CNC project is just the same. Some projects require parametric modeling software like a Libre or Fusion 360. The ability to analyze the shape and choose from 100 different tool pathing options is needed on something like a putter. However, many terrific builds are made on basic 2.5D software. Carbide Create was the correct tool for this job. Now, the most intriguing part of this build, the use of hidden door hinges. These guys are sweet little pieces of engineering that I picked up on a whim while exploring Amazon. Occasionally, I'll throw a bit of money at something I think may have use somewhere down the road. This means things sometimes go unused, get lost in my garage, and are never seen again. Though more often, it means that item's presence will percolate in the back of my brain, bubbling up when just the right project comes along. 8 months back, I threw these guys in my cart. Now it's time they exit the drawer and pay off. Taking measurements and planning proper depths is needed here. I spent some time designing and testing these hinges to ensure proper alignment between the halves. Dialing in the distance from the hinges to the edge of the folding joint is critical. Getting that spacing between the hinges just right will take some testing. Ignoring it will cost you nearly completed projects. Ask me how I know. I begin by measuring the distance between the pillars of the open hinges. Measuring 3 hinges gives me an idea of just how consistent these particular hinges happen to be. In that total measurement, I need also to account for the slight gap between the halves. It took me 3 tries to get this particular hinge to function smoothly. Each version got approximately 0.5mm or 0.02 inches closer to the edge of the joint. Keep in mind, this meant for the joint, each adjustment was a total of 1mm as both sides of the hinge came in 0.5mm. Cutting smaller test parts with 2 hinge positions allowed me to quickly iterate. For this, I made a separate file in Create designed explicitly for hinge testing. Once I found the dimension that worked, I copied that design element back into the larger Carbide Create file. Which brings me to an error. Do you ever make errors? Do you ever fail to notice them until it's too late? It even happens here at HQ. At some point, I accidentally altered the depth of cut for the hinge insets, and I didn't see this until I had already assembled the boxes. So, what to do? I made a quick template guide, grabbed our standard trim router, and 20 minutes later, the hinge part is routed to the proper depth. CNC showing its versatility. Additionally, there must be enough room for the edges of the joint to pass one another. I learned this while making smaller game-based projects with barrel hinges. And I'll tell you something, I love making games. Cribbage, backgammon, these boards, I love competition of any kind. I love competing with my friends at go-karts, video games, cards, darts, even jarts.
What?
How we survived the 70s and 80s, I'll never know. Putting a chamfer along the back edge of the joint makes that articulation possible. I went with a 4mm deep chamfer line using the number 301 90-degree V-bit from our catalog. For this version, once the box was assembled, I had to add the chamfer to the side part. Now, you could reincorporate that into the original design, but here I just filed it down. Sometimes the most analog of tools are the best tools. By the way, if you want to create these boards yourself, the file is available for download over on CutRocket. You will have to adjust the design for the exact thickness of your plywood, hardwood, or whatever material you may use for your personal version. Testing behind me, I laid out all my parts across a full sheet of plywood. This is where I used the tiling feature of Carbide Create Pro to conceptualize my production of parts. Tiling is typically thought of as a way to make objects far larger than the machine bed. We've done a couple of videos highlighting that application. Tiling can also help you use a single set of toolpaths to cut multiple sets of parts out of pre-cut sheets of stock. Here, I've created 3 32x48 tiles across a sheet of plywood. The project only requires 2 different sets of parts. The top group is there as a layout guide to ensure that I can fit another set of parts within the sheet. Pre-cut pieces become each tile dropped into the machine. Running my programs, I'm getting 1980s parts tree vibes. Did anyone else love building models as a kid? Cars, planes, tanks, all with decals you had to soak in water and then slide into place? Always trying to get that photo on the box paint job with just a brush? All while getting high on fumes from that tester's glue? Takes me back. This project was also the first one where I had a chance to challenge our 80mm spindle. It's a 220 volt, 2.2 kilowatt water-cooled unit. The increased power and half-inch tooling capability really shined. There are many times when I think people are unnecessarily obsessing about the time savings of certain strategies in CNC. This is one case of the spindle making a significant difference in time on a single project rather than needing to run 100 or 1000 of something to save enough time to justify the cost or hassle. Tile number 1 is estimated to take 44 minutes utilizing a half-inch end mill for the majority of the cutting. When the program is switched to a 1/4-inch end mill, that time goes to 104 minutes for the same tile. This increases the total machining time on the project by 4 hours. Now about those time savings. They come because of the increased rigidity of the tool. Rigidity stands in for a few different factors, including but not limited to greater mass. That spinning mass of a half-inch bit is nearly 4 times that of a 1/4-inch. Greater mass produces increased stability. That mass reduces what is known as chatter or vibrations at high speed. Less chatter equals cleaner cuts. You also get better grip. The collet has more surface area to grab, thereby making the bit more secure. This allows higher cutting forces to be tolerated without the collet losing grip of the end mill. Half-inch bits are also less susceptible to deflection, which is something that happens anytime you pass an end mill sideways through material. 3/8-inch tooling offers some of the same advantages listed above and probably has a role in your 80mm spindle. If you cut large sheet projects regularly or want to work with 8/4 wood, this spindle and tooling could be for you. Now it's time to see Kevin be impatient with the project, want to see it complete, and make another error. Hence the overuse of the nail gun. I could have simply assembled the frame with the nail gun and glued it to the underside of the top. This is in fact the benefit of the precision of CNC, but I'm an idiot on this one. It won't affect gameplay or function, but it could look a lot cleaner without the nails, which, once the glue dries, aren't doing anything anyway. Oh well, third board kind of thoughts. Even before this first board is complete, I'm already brainstorming ideas for version 2. I deliberately decided to build one complete board before making major revisions. This allowed me to make notes and apply changes with a clear picture of the overall project in hand. The willingness to try something despite never having done it before, and then make changes to try a second or third time, this is how you become proficient, or something another person might call an expert. Just the other day, I had someone ask me, "Have you ever made carbon fiber body panels for a car before?" I said, "Not yet. Talk to me in about a month." Due to the changes I made for board number 2, I'll end up with what is not a matching pair in design, but a matching pair in function. Tell me which version you prefer and where you'd go from here. I explored such areas as lightening it up, storing the bags inside, and lessening the add-on equipment. Some of those ideas worked and some didn't. One idea was added back into box number 1. These little frames are going to keep the bags in the boxes. Storing the bags inside does make the boxes heavier, but it's one less thing to carry. Version 2 could be hardwood, could be half-inch plywood in parts, could be pine, or maybe even foam if weight is your main concern. Back to the beauty of a cornhole build, aside from the top dimensions and the height, it's your canvas. Now the legs became a journey by themselves. I set out to do something different than the usual foldouts. I know they work, blah 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 blah, but this is where two camps of people in CNC definitely differ on what to do. The engineers and the artists. Engineers, if you have a solution, never change it. Artists, on the other hand, are always looking for new ways to solve existing problems. So here, artist Kevin found himself moving over into Fusion 360 to exactly define the angle and dimensions of the part. After creating that dimension drawing, I exported it back into Carbide Create. The cuts are simple, the job setup is already made in Create. Importing that drawing was a much quicker method for getting the feet manufactured. I think the design of these feet is a stylistic match to the rest of the build. Are they a reasonable departure from the normal style? Again, you tell me in the comments. This configuration did set up the use of another interesting pair of hinges. These locking guys are new to me, and I could see them percolating up for another project. I definitely dug the opportunity to use them here. Finishing is another area for creativity. You're liable to have 1,000 debates on the subject as you continue making things. I went with gel stain for some racing vibes and its propensity not to bleed across the material. 4 clean lines later, and it's 4 coats of semi-gloss polyacrylic on each of the tops and 2 to 3 coats for the edges. Endless debate can be had when it comes to finishing. My main concern is that both boards play the same. Perhaps I'll have to make some alterations if the slide isn't playable. So far, it seems reasonable. I'm confident that boards 1 and 2 will play quite nicely, and if I built board 3, it would be perfect. That's usually how it goes. Carrying these, I would definitely explore further lightening. Perhaps a change to 1/2-inch plywood for the top surfaces is the easiest win. I think I'd also go with both the paracord handles and the integrated cutout handles. The multiple sides with cutout handles is terrific for loading and unloading the boards from the car, while the paracord handle is comfortable for a longer carry, say, to the beach. At the end of the day, these boards are still big. There's just no way around that. But they are far more portable because with a 24x24 footprint, they can now easily fit in nearly any car's trunk or back seat. Additionally, taking them through the doorway of any house is easier. How would you change or evolve this design? Let me know. For now, it's time for me to find a good place to dream up my next design adventure and perhaps pick up another victory. Thanks for coming along this time. More information, ideas, and inspiration from Carbide 3D are on the way.